My name's Clemens. I work for Microsoft. I'm the architect for messaging in the Azure platform, so I'm a cloud guy. And I've been doing this for the last about 9 years of my 10-year career at Microsoft. Before this, I've been doing also distributed systems. I have been around in the SOA world for a while, and so I'm very happy. I did this talk yesterday at the same time about microservices messaging and distributed architecture, so I'm very happy that the thing that we did 10 years ago is now hip again. A thing that I've started working on about 4 years ago or 5 years ago was the Internet of Things and how that relates to Microsoft, how that relates to us, and how that really relates to cloud, what the attach point there is. And we've meanwhile shipped some product. I'm going to tell you very little about the product at the end of the talk, but really what I want to do with you is kind of speculate a little bit about the future. Because we have a lot of drivers out of the IoT which are right now a little fuzzy and like what this is all about. And a lot of what we see in the trade press, certainly in TechCrunch and Gizmodo and all those places, is little consumer devices, which are not very interesting, at least not for me, because I'm about, for me the future is something that's about connected systems, that we're leveraging all those devices, all the stuff that we can go and do now through this hardware revolution, through hardware becoming more accessible, easier to build, that we can go and connectivity being cheap, that we can build some more interesting things. So there's a kind of running gag, a meme almost, with this Maslow pyramid of human needs: self-actualization, esteem, social needs, safety, security, physiological needs, kind of that, and then you have underneath that Wi-Fi as the most important thing. So that's a meme that's going around the internet. It's interesting, if you look at this pyramid, like seriously, from what that means in terms of, what do services satisfy that we have, that we use, you can actually use this in a very serious fashion. So let me try that. There's a border here between physiological needs: air, shelter, buildings, heat, energy, weight, water, waste, food, sleep; safety and security, security, physical security, safety, stability, protection, order, law, all those things that are just the foundation for our lives. And then above that line is kind of all the social stuff, right? Interconnecting between people. There's pure us sustaining life and not dying because there's anarchy. And then there's what makes life worth living above that. If we think about what internet services do today, what services we use, most of them all sit above that line. They're about our social lives, they're about our business lives, they're not really about foundational things that make our life worth living. They're not about that keep us alive. They're about what makes life worth living. That's all tools and toys. Under that is infrastructure. And the infrastructure is the piece that I find actually most interesting about the IoT. And for me, that's the line that I draw between the web and the line and what IoT really means. IoT is ultimately about security, safety, and is also a driver for a lot of those things. So here's what I think about as infrastructure: a big collection of stuff that we can go and use digital services to make better. So there's city, buildings, energy, health, mobility. And then underneath that, I just pick energy: electricity distribution, wind, solar, geothermal, gas distribution, fuel distribution, power plants, nuclear waste, coal mining, oil, gas production, exploration. All those things are fundamental for us to be able to sustain our society, to sustain human life. And that's true for the city, it's true for all these different scopes. These are all very interesting areas where we can use digitalization to optimize, to get more transparency, to monitor. For me, that's where it's at in IoT. It's not the Arduino that knows what's on TV, and when your favorite show comes, it beeps, right? That's a thing on the internet, and that may also be interesting, but it's not Internet of Things in the way I look at it. So what can we do as software people to go and make the world a better place? How can we go and make those systems better, more efficient? How can we get more brains on this planet? Because ultimately, my brain, your brain takes about 20 watts. It's a supercomputer, right? Google tried to, with AlphaGo, beat and got beaten once by a human who ran on 20 watts. With I don't know how many thousands of cores they spent on this, a ridiculous amount of energy. We have a super efficient supercomputer in our head. It would be great to have more of those supercomputers on Earth and be able to go and sustain a nice life, because I think overall we would get much further than with trying to replace all those supercomputers with AI, which runs on less capacity for more energy uptake. So there's a ton of opportunities here. Process optimization in industrial automation, in logistics, energy management, environmental protection, security, safety. And I'm going to walk you through some examples of stuff that exists. And I'll also point out that none of these things, very few of these things, are really standardized. And certainly none of those things are standardized in a way that the world could take them. But there's a ton of good ideas. And I think we're going to go and see consolidation in a lot of those areas. The first one is, in this last talk of this track, is the one that we started with in the keynote. This is an autonomous car. Well, it's actually a highly automated car. Highly automated is this car is capable of driving itself completely without anybody holding hands in a very reliable fashion, and arguably probably better, more reliable than the Tesla, certainly judging by the pictures that we saw. On an Autobahn. There is no spinning nonsense that's kind of up the LiDAR that's up on the roof for $250,000. This is a stock production Golf that has been modified by IAV Automotive Engineering, who are a company that you usually don't hear about, but they are building active safety systems for a lot of customers that they have, and their customers are OEMs. So it's quite possible. I know that in my car there is technology from them, and there's quite possible that in your car there's also technology from them which helps with active safety systems. Active safety systems, the first wave has already arrived. You may have seen ads on TV where the Mercedes guys are claiming they can no longer run over a car. This is wonderful little commercial with the kids trying to run the cars into each other in the living room. They can't. Automated braking is the first step towards that. That is now existing in BMWs, and Audis, and Volvos, and all those braking assistants are already there. What they do is something that we heard about this morning. They will, and this is something that it amazes me that the Tesla actually ran into that accident. All of those cars, when they have a front-facing camera and radar systems, are going to be required actually from next year to have automated braking. Automated braking means if the car can see that there's something in the way, it has to brake automatically. And it needs to make that decision in the right time. So that's what's interesting about this, is why I bring this up in this context, is because the only thing that drives sales of those kinds of systems, the only thing that really motivates automated driving is safety. That's why it's all happening, and that's what people buy. And active safety systems and driver assistance systems is the #1 option that people buy for vehicles. So right now, when you buy the latest generation Audi or BMW or any of those cars, the options that are most chosen are the driver assistance systems. So that's a significant market driver, and the assumption is that they just get better. We already have lane keeping, and we have side assistance, and we have radar guidance, so we are kind of already down the path of autonomous driving. But most of that is really motivated by safety. Safety, health has to do with looking around the environment. So there's a number of services that are interesting in that way. I have two here from Microsoft Research. One is New York City City Noise. That's part of the New York City 311 platform, and people can report into that platform when things are too loud on their block, so that the noise pollution in a city, in a massive urban area like New York City, stays under control. That's an insulated solution that works just for New York City, but it's part of the official platform of the information platform of the city, so that noise pollution can be reported. Noise pollution is also automatically reported. There's microphones in the area, so that the city then can go and react and see what the noise pollution comes from. Beijing is not a very happy place to live in, unfortunately. Many times of the year, people who are going there, I mean, there's millions of people who live there, but people who go there report that they have a hard time breathing because Beijing is terribly polluted, and it's dangerously polluted. There's measures being taken right now, but to take measures, you actually have to know kind of what's going on. And there's an urban air project also run by Microsoft Research, which gives a fairly accurate, I probably have to, here you go, a fairly accurate picture of what the current quality is in Beijing. So this is live data. Oh, you don't? Huh, interesting. Oh, because, hang on. Sorry. This is me not duplicating the screen, because usually I do. And now I gotta go and fumble this. Okay, so this is Beijing. Even though you see this in German here, it really is Beijing, because this is Chrome trying to be helpful. And translating the Chinese for me. Well, thank you very much. So that's effectively the pollution factors, and so you can go and kind of click into areas here on that map, and kind of get the but not if Chrome is getting in the way of this. Okay, so that's kind of the air pollution indices for that corner in Beijing. So they have effectively a network of pollution sensors that are set up through the city, so that there's transparency about what the pollution levels are. Let me get this out of the way again. Usually I run with duplicated screens, but the gentleman here told me that I shouldn't. So that's the cost of that. Okay, there we go. Another one is, and this exists in many cities now. I'm not going to go to the websites again, but I have screen copies of most of them on the slides. Traffic management Düsseldorf. So that's close to where I live. I live near Mönchengladbach in Germany, so just over the border from Venlo. And so the city of Düsseldorf, they have the city management has a very accurate database, geodatabase of current events, current traffic situations. They have a forecast of what's going on. So if any of the big venues, the sports venues, concert venues, etc., if they have events, they have all of that in that database. And that's, if you think about autonomous driving, if you think about automatic routing of buses and all these things, that's all information you need to have. You need to know what's going to happen tomorrow so you can go and optimize for traffic, right? So this is a database that they maintain that you could leverage, and that has all current information. The problem is that there's no standard for this. So that's starting. In Seattle and a number of other cities, there's a project that I like quite a bit called One Bus Away. One Bus Away is a non-profit organization that is trying to patch up what the city of Seattle can't fund, or the King County is the region effectively around Seattle. The problem in America is that public transport is not very much in favor. And if some money is needed for something, it usually gets cut out of the budget of public transportation. So bus transport gets worse, not better. And one of those things that they could not fund is kind of this real-time information network to know what happens where and which bus is where. So One Bus Away actually built this, so the real-time information about which buses where is needed for monitoring the buses. So they're tapping into this, and they're providing effectively for the riders, they're providing real-time information, which is really well done, about where buses are. And that's a research project by the University of Washington, University of South Florida, Georgia Tech, and that also exists in Atlanta and some other cities, where they're effectively patching up, the universities are patching up the deficiencies of the public transportation systems, which is interesting, but also very sad. So what can you do with creating transparency on routes? So one of the things we have on Microsoft Campus is a pretty clever model for how we go and do, we get around on campus. Campus is a little city. It stretches over, I would say, about a kilometer, well, probably 1.5 kilometers by 2 kilometers. It's fairly large. And there's like 100 buildings. And so getting from one place to the next for a meeting within 5 minutes is kind of a big deal. And there used to be fixed routes, bus routes that went around campus. And now it's kind of a there's still a notion of a route, but it's mostly peer-to-peer traffic. And so we have something that's similar to this here, which is, I made these slides first, and then I actually found out that the system that we have on campus is kind of like this, so it's interesting. So you have people who are waiting at a bus stop on a route and want to go this way, and you have people who want to go this way, and you have people who want to go that way. And you have buses. What you can do now is, if you know how long it takes usually takes from and to each stop, and it's Sunday morning, then you can go and start cutting corners. If you have public transportation in the busiest time, you really want to go your route, because then you can't predict it. But in off times, you can go and start cutting corners if you can create transparency on the bus stops. And creating transparency on the bus stops is a very simple IoT project. What do you need? An infrared camera, and a button. 2 buttons. This direction, that direction, maybe, or this line or that line, and an infrared camera. Why do you need to have an infrared camera? Because first, there may be an old lady who doesn't understand what that button stuff is, right? So she'll just stand there for 2 minutes, and then you're like, let's press that button for her. So that's one thing. And then the other thing is, there's the 8-year-old boy who presses the button and runs away, right? No signal on the infrared camera, we won't come. So that's kind of, you can imagine that creating transparency on the route. And then you can go and cut corners and make the route more efficient and get those people around. And that's actually what we do. We just don't we don't have infrared cameras, but we have receptionists who help us kind of check in. And then you also, meanwhile, there's an app they can go and use. And now, even though we still have routes, the routes are cutting corners because there is transparency now on campus. It also allows you to create ad hoc stops, right? You have people who are showing up and who are connected and who say, hey, I'm here. Why don't you send a bus in, right by the route and not necessarily here? And that's something that's certainly possible. And that's how do you combine the concept of Uber or Lyft, which I like better, with public transportation? Because ultimately, I think that public transport is going to become more on demand and is going to be bigger competition for the Uber folks than certainly in Europe than private drivers. Create these ad hoc stops, and then obviously you can also dynamically route. So you have people who have a calendar and they know exactly where they need to be where, and so you can go and correlate that with the bus system, and then you can go and tell that person, hey, if you want to get to your next appointment, you want to go and take the bus, then you have to get up now because right now there's a traffic disturbance, so the bus is going to take a little bit longer. So you can go and integrate the scheduling with the bus route. And that's all required. That transparency is also required when we think about public transport, because we want to get to e-mobility. We want to get to the point where we can actually go and do electric charging for all those cars, certainly for public transport, so that we can get the use of fossil fuels down because we A, have to, B, because we have to. And creating an e-mobility will require that you have loading stops. You need to charging stops. That you monitor the charges on the buses much more tightly than you do that today with your fossil fuels. That you need to go and take buses out of circulation, you need to go and put buses back in. So there's a lot more work that needs to be done to make that e-mobility stuff work. And again, for that's the infrastructure that's motivating, because that's preserving the environment. That's the infrastructure that will motivate a lot of the change of the infrastructure towards that. It's what's the driver for autonomous cars? The driver is safety. For public transport, the driver will maybe e-mobility. Like, where's the money coming from? The change towards the shift towards renewable energies is something that we, certainly in Germany, take enormously seriously, stupidly seriously, some people say, because we are in this. Since we said no more nuclear, and we're abandoning all the nuclear plants, and at the same time, we also don't want to have any of the coal anymore. Then we're now. What else is there? What else is left? It's an interesting puzzle to solve. Ultimately, renewables will be required to do e-mobility, I believe. And the reason for that is the transfer capacity. You need to have local. You will need to have local power generation close to your charging stations in some way. And that's something that's easier to do with renewables than to go and cart all the coal everywhere, or you do little nuclear reactors, right? The reason for that is very simple. You think about how much energy is packed in a liter of fossil fuel, and you try to calculate that out, how much battery and how much transfer capacity you actually need to have on the wire. That's pretty crazy. We're not even close on the current electricity grids to be able to go and do this. And there's currently a lot of talk about in Germany about creating these big transfer lines for electricity from the North Sea down into the south. And that's going to take just that. Those transfer lines are going to take another 6, 7, 8 years to build. So e-mobility in the $35,000 Tesla for everybody is not going to happen until we've solved the energy issues. And the management that comes with it. The management that comes with it is actually probably the more remarkable one. If you try a grid, electricity grid, runs on voltage, right? High voltage transfers. Voltage means that you have effective tension in the system, right? That tension requires balance in the grid. That balance requires that you have kind of about the same kind of level of production from where you produce energy to consume energy. You need to go and keep that up. Renewables are interesting because renewables are not as predictable. Also, if you only have 10 power plants in your grid, or 20, versus having a solar collector on every roof or in every farm that also produces, that also puts stuff into the grid, now the management of the grid becomes much, much harder and requires information about who's producing what, and also prediction about what is going to be produced. The management becomes much harder. So here's a really interesting case study by ENTSO-E. ENTSO-E is an organization that is of forced marriage. Sometimes it looks like that. It's an organization where the operators of the electricity grids cooperate in Europe, and they cooperate about transferring data between the operators to see how much power is where and how it needs to be distributed, and they shift the electricity effectively around Europe with their operational systems. So they're called TSOs, and that's how they run the European grid. This case study here is from last year in March, I believe, or May, where we had a large solar eclipse. The solar eclipse happened in the morning, started at around 8:30, and then lasted, as you can see on that graph, until about 11. The delta between the normal uptake of energy and what was available as energy capacity from renewables was 17 gigawatts. When that solar eclipse came around, when the sun was out, solar and wind both dropped to the bottom because no sun, no solar is clear, but then also it's having effect on the wind, so that also dropped out. So what ENSO had to do is they had to go and take the nuclear and power plants, have them on standby, and as the moon moves over the sun, they had to go and ramp them up, and then ramp them down again so that they could go and deal with all this. It's an enormous thing. You can see this is the frequency maintained throughout the entire event on the grid. So they did a really good job on doing this. But that's magic that you never think about. And it requires a ton of real-time coordination between all those TSOs to make that all happen. By 2020, 60% of the capacity in coal and nuclear plants, which has been used to even this out, will be gone. So that'll be an interesting time. So we're getting into we live in a place of, you know, when does the energy grid go down? Like when do we actually have outages in Europe? It's rare. It almost in the U.S., right? The wind blows, power's out. But here we live in a pretty stable place. But might change because it becomes harder. So there's a technology race going on of how we can go and keep the grid stable. One of the ways of how to deal with this is more and better batteries. There's battery technology, batteries like the Tesla battery, which is put together from many small batteries, or batteries in this form. This is the Köpfchenwerk in Germany. There's others like this, and the way how this works is there's a lake at the bottom of that hill, and this takes power, pumps the water up the hill, and when power is needed, the water runs down the hill through a generator. So this is a battery that's using a lake. And that's hydroelectric principle, and it's also used in many other places. And that's one way to go and deal with that problem. And that is, you take the energy that comes from wind and the energy that comes from solar, you pump water up the hill, and when you need power, you go and then use the reverse effect, and you just generate power again. So we need batteries, but that also needs to be managed. ENSO-E, the transparency.ensoe.eu is a fabulous site. You're going to have those slides on the share, so you can go and click it from there. And that actually shows in real time who's buying power, who's selling power, and it's called transparency because that's all for us as citizens of the EU to go and look at, which is pretty fascinating. Industrial automation is another area which is a huge area of optimization. And industrial automation has been doing IoT for the last 40 years. Since, well, arguably for the last 47 years or 46 years, 1969 was a fabulous year, by the way. Moon landing, I was born, fabulous year. And I was born just a week after the moon landing. The guys came back. A week later, I happened. Anyway, so industrial automation, they're doing IoT for the longest time in that sense of having actuators and sensors and all strung together and exchanging digital information, but mostly just inside of these machines. This is, by the way, a bottling plant. The bottling plant needs to go and communicate. So there's individual machines here which are built on top of real-time buses, and they do many operations very quickly. It's a fully automated thing. But if you want to go and communicate between those machines, that's something where the vendors of those machines may be different. That's also not hard real-time. That's like coordination. You have the machine that makes the bottles, and you have the machine that fills the bottles, and you have the machine that goes and puts them all into cases, and then you have the machine that puts the cases onto a pallet and then wraps the pallet and all those steps. And they also need to go and coordinate, and that doesn't happen on a real-time bus. That happens differently. So one area where we are directly engaged, and I'm actually personally engaged in, is OPC UA. And OPC UA is a standard for 180 automation companies that are working together to make all of that stuff gel and make communication work. And in industrial automation, we're coming out of a world where everything is proprietary. You buy something from Siemens, and then you buy also everything else from Siemens. You buy something from Bosch, and you also buy everything else from Bosch. You buy something from Beckhoff, and then you buy everything else from Beckhoff. They like it that way. However, because systems become more complicated, people have learned, hey, we have to go and make those things interoperate. So we have OPC UA. And of course, OPC UA has been around for a while, but now it's also required to go and take those industrial systems and connect them out to the cloud, connect them out to IT systems, which can then go and optimize. And so we have, and that's something that I have contributed to, extended that specification with a PubSub capability, so that it can now publish out, that the devices directly can go and publish out to the cloud or can publish out to data center systems, into message brokers, to deliver telemetry, to deliver information, so that that information can then help streamline the systems. There's more interesting stuff in the area of home automation. So that was industrial automation. Home automation is an area that I have the Honeywell thermostat here just because everybody has a Nest thermostat. I hear they're not doing so well. That's an interesting area, mostly in the area of smart buildings versus smart home. Smart home is, who has a smart home? Okay. Automatic everything, right? Who wants a smart home? See, that's the problem. Because I don't care. Like I'm perfectly fine having my semi-automated way to get the window blinds up and down. I don't need to walk into the house and say, make it light. No, I can touch that switch. It's okay. I don't need to talk to anybody. And that's true for a lot of people. The home automation thing is something that the geeks think is the hottest thing in the world, and where normal people are like, what do you want? Like, we as geeks, we're kind of happy, and then we have the non-geek wife or husband, and they're like, no. But still, building automation is a big deal. Because building automation for commercial buildings like this one, that's something that needs to work, and that should be working in an automated fashion, because the guy who's running the show, who's running the building here, and who makes sure that the climate control works, well, he's not here flipping the switches, no. Please, the room here should not be too hot, should not be too cold, and it should be, automatic. So that's something that is for building automation, for something that is like a dynamic venue like this one. We want to have automation. So building automation is the place where it's at in terms of automating the houses or buildings, and not so much smart home. At least that's my impression right now. Then we get into areas of public safety. Here's Elbpegelstand. Also another wonderful insulated solution. Elbpegelstand.de, Pegel Online, that's a service of the federal government and the German federal government. And Elbpegelstand, uniquely, just for that one river, who knows why, has a Twitter account. And that Twitter account tweets out the level of the Elbe, and which is nice because now you can go and start building rules and IFTTT on top of that, etc., which is great. It would be wonderful if that was something that they would do for the entire country, but they don't, because that's another one of those trial things, right? But it's growing. You can see that that may be something that will be useful in the future. USGS, the US Geological Survey, has a ton of services around water. They have near real-time water stream flow data that you can go get visualized, that you can also get as data streams. So if you live near a stream and you want to go and do fishing, or you want to go and navigate the stream, or if you're just worried about stuff breaking down or being washed away, that's information that you can use. Earthquakes. Whenever anything happens, and when I see on Twitter earthquake, anything, this is the site that I go to, USGS, earthquake.usgs.gov, worldwide coverage for earthquakes and earthquake data, earthquake news, very good. That's a global service, effectively. Google Maps, traffic information, obviously. There's effectively 3 big vendors, Google, where you can get your information, and the way that's done is through your Android phones. And through your car. So if you carry an Android phone with you, you're contributing to that map, because they're correlating your location to whether you're on the street. And if you're on the street, then they're going to measure the flow, and that's how they figure out whether there's something slow or not. Similar things happens with TomTom, with the TomTom navigation systems, and also for Here Maps. So these are the 3 big services that kind of give you real-time traffic information if you want that. And then there's other, like your car, maybe using this. The Here data, I believe, is what, for instance, is in my car. So I have this online service that I have from my car manufacturer, and that gives me data with a resolution of at most 5 minutes delay, which means I'm often out of from the highway before everybody else is, because the other systems run through the radio and have a lag of up to 20 minutes. And so I'm actually, my car knows about those traffic stops earlier, because mine is online and doesn't work through the public radio. Lightningmaps.org is very, very, very currently interesting for all of us because of the unfortunate weather we're having. I always blame Holland because I live right by the Dutch border, so all that bad weather comes from you. Lightningmaps.org is fantastic. What it shows is real-time lightning strikes, effectively across all of Europe and some other areas of the world. So if you go to lightningmaps.org, if there's bad weather coming, and if there's thunderstorms coming, you can see if you see the flash of the light, they actually tell you what the latency is going to be. You see the flash outside. 2 seconds later, you see that dot, and they actually have a circle for what they calculate how far the thunder goes, and the thunder is actually a ring that goes around it in real time. Sometimes they kind of do prediction on this. So sometimes they just where you live, when the thunder wave hits you on the screen, that's exactly what the thunder shows. It's astonishing. It's really cool, and that's what I use. Like when my wife says, "What do you think what the weather is going to be like?" I showed her now. Now she's looking herself. But that's how we tell, because you can see whether there's something bad coming up from Belgium, whether there's something bad coming up from over Eindhoven. That's kind of usually what hits us. It's astonishing. So that's also interesting data. You can also use flight radar, FlightAware, give you live information about traffic. I'm actually contributing to that. I have a little ADS-B receiver in my house. It's a Raspberry Pi. I have an extra antenna on my house for 1090 megahertz. And I'm actually contributing data into flight radar, FlightAware, and Plane Finder with that. There's also a little IoT application, if you will, and you can go now see what's above you. And I have a pretty big camera, so I happily shoot pictures of planes that are like 36,000 feet in the sky. And I still can get them kind of full-frame pictures, which is kind of fun. It's a very big camera. So FlightAware is the same thing. Marine traffic is the same thing for, you are people close by the sea, so that is going to be more interesting for you. Marinetraffic.com, very similar for ships. What's going on? What is the ship like? They have like VR things, and that's also working in a similar way. AS data is what they collect. So digital infrastructure in the way how I understand it, is what you kind of collect as data, what we collect as data under, from sensors, from civilization infrastructure. And sometimes there's already a notion of API. And I think one of the things we're going to see happen is that there's going to be standardization around that, so that there's going to be APIs for cities, and APIs for states, and APIs for countries. And sometimes for like earthquake information, an API for Earth, where you can go and now start building solutions that are on top of that, and they're using that information, because the data is ours, right? Like, as an EU citizen, the EU data, I want to get something from Brussels. That would be fabulous if I could get that. If I could go and build on top of that. If we had digital infrastructure, if we had digital utilities in that way. The problem is tiny islands. This is Germany in 1648. All of these are different states. You needed to have visas to go between those places. Well, that's passage permits. We fixed that meanwhile. And see, the United Netherlands, you fixed that earlier. Right up there. And that's the state of all of these digital infrastructure pieces right now. It's very small. It's all POCs mostly, small things. But a lot of them are interesting and very promising. And I think we're going to get there to make them more meaningful. How far can that scale? How do we get this? What is the opportunity? Well, I think for a while there's going to be all of these different diverse sources of data, and all the different, it's hard to believe that all the cities and all the states and all the countries will go and agree. So there's opportunity for companies to go and collect all that data up, normalize it, and then make it available. So those APIs may be commercial for a while. And we see the first trends towards that. That you're offering a service where you are normalizing all that data and you're providing that out to others. What you need for that, to make it work for cars, to make it work for infrastructure, is you need to have a lot of scale infrastructure, high-scale infrastructure. And I think, and we believe that's kind of where we can contribute. The architecture, the requirements for these architectures are extreme, because we always talk about utility scale. We talk about all the houses in an area, right? All the people who live there, everybody who uses public transports, all the cars. So we're not talking about tens of thousands. We're talking always about hundreds of thousands or millions. So that requires infrastructure to deal with that. It also requires a lot of security. We have to go and make all of that very secure. We have to go and secure the cloud. We have to secure the gateways, the infrastructure that sits on the side of the road. We need to defend all the devices. We have to let go of some legacy attitudes that we have towards security. Today, security, specifically in industrial systems, is typically mirroring physical security, right? You make a wall around the building, and then you have a door through which you can come, and that's how many of the VPN setups work, right? You have a factory floor, nothing is secured, but yes, it's ring-fenced, right? Nobody can get in there. And the way how you get in there is there's a door, so you come through the VPN. Of course, that's all nonsense, because you can go and this is how Stuxnet works, right? You can also get in through a USB stick, and then that works against you. So we need to get rid of that attitude. We need to go in and take security seriously and defend everything in depth. Otherwise, that's not going to work, because all of the things that I told you about so far are under that line in the pyramid, where it is about our safety and security and all this. And security is something that we need to go and take very seriously. I'm going to skip that one. So showcase industrial automation. So that's the old. We have this old model, kind of, where everybody can talk to everybody. And we have these gateways, which are now talking on behalf of that external network, but that communication happens at the application layer and doesn't fuse two networks. So that's one way to deal with that. So security needs to be kind of a key element in all this. So how can we help? So here's a quick pitch. We're going to make this very quick. First of all, we have a ton of infrastructure. We have 28 global data centers, more than anybody right now in terms of total footprint of data centers that we have. We have the second or third largest network in the world. That's always like sometimes one day we're on top, other day Google is on top, but we operate one of the top 3 networks in the world. On our own fiber, we have sea cables that are our own. We have a ton of infrastructure that we run ourselves. If you come from Europe and you hit a service in Azure, your bits land through a sea cable in Virginia and go in Virginia on Microsoft fiber, and then go to whatever data center you are in the US. We have a huge network. And we have all these data center facilities. We have over 200 data center facilities in the world. And that's a great foundation to go and build services on top of. We have built for these kinds of systems a reference architecture model that we share. If you search for Azure IoT reference architecture on the web, you'll find a PDF document that you can go and read. So I'll just point that out, which kind of gives a general categorization of the services that you need in the cloud to go and kind of build that infrastructure. Generally, what we find is that there's a general pattern for attaching lots of devices into a central system. There's a notion of a gateway. There's a notion of a hot path, of a gateway to get the data in. There's a hot path where you want to go and do compute on the hot path while the data is super fresh. You do this with Stream Analytics, that's a service that we have, or with Hadoop Spark, Hadoop Storm. Any of those infrastructures, we support all the Java infrastructures that are in the Apache ecosystem as part of the Hadoop ecosystem that you can go and run. And there's, of course, all the cold path analytics with the rest of mostly of the Hadoop ecosystem that you can also go and run in all this. The focus that we have in all those things, and this is why we built, and this is the thing my team built, is the focus in all these things is scale. And we build infrastructure, specifically platform as a service infrastructure, whenever you need massive scale. Event hubs, for instance, is a way to go and get telemetry in the cloud. The way you set this up is not by there's 2 ways of setting something like this up. You can go and install Kafka and run it on VMs, which requires you to go and install it and run it on VMs. Here, you can make an event hub, which is effectively you just wish for one, and the thing gets installed for you. This infrastructure today, the event hubs are, if you know Kafka, you know event hubs, so the principle is about the same. It's a different foundational infrastructure that sits underneath. This currently runs 3.5 trillion transactions per week deployed. The growth rate that we have is well over 10% month over month in terms of traffic that we run. We run over 20 petabytes of data through this per month. And that's for super large scale ingestion. We built those services that infrastructure that is doing stuff at that scale, that is doing the hundreds of thousands of things somewhere, can go and use this. On top of that, builds IoT Hub. And IoT Hub is an infrastructure that's leveraging the same foundational technology, but then is specific to devices. It is built so that you can have bidirectional relationships and security relationships with 1 million or 10 million devices at the same time as infrastructure. So it's a super high scale infrastructure, speaks HTTP, MQTT, AMQP, that exists so you can go and take devices, you can get data sources that you can also go and send control commands to and connect them up to the cloud. Yes, we know that there's also compute at the edge. We're supporting that too. So part of that is also SDKs, which allow you to go and integrate stuff that's at the edge. We're engaged in the Open Fog Consortium because we also know that we have to go and integrate in the edge more in the network, push compute into the network. So we're working on that as well. And that's what I brought you today. I hope that was somewhat entertaining as the last session of this track. And I think there's a closing keynote coming after this. Thank you very much for being here. Thank you very much for listening to me. Oh, you cut me off because you still want to ask some questions.
Yeah, we still have some questions.
Oh, good.
Clemens.
Well, then let's go and answer them.
There is an interesting question. I was wondering myself as well. You showed the Volkswagen Golf stock car, right?
Yeah.
And you said, well, this car is more safe and more secure than what you see from a Tesla and
yes.
from the Google. How are they achieving that goal without all the sensors and the cameras and the...
They have so the Volkswagen Golf, if you buy the latest, the current generation Volkswagen Golf with the automatic assistance pack, it already has the sensors in it that are required. So the capabilities of that particular prototype that you saw is using the exact camera, the production camera, and it's using the production radar that's already in that Golf.
Wow, that's impressive. Okay. Another interesting question is about electronic cars and the opportunity that they have to overcome actually the energy gap that you showed. With what opportunities do you see there?
So we have a actually hard energy transfer problem. And we will have that, because if you calculate out what the potential energy in megajoules is, what actually sits in a tank in a gas station, it's enormous. If you think about moving that using transfer poles, it's possible. It will take weeks to fill one of those tanks. So I mean, it's not instant. How do you do this? Well, first of all, we need to have a revolution in battery capacity. Battery capacity needs to get as good as fossil fuels. And then we need to do decentralized energy production. So I think the windmills, the new windmills that we have now all across the country, I think that's going to get worse rather than better. Because if we want to fill our energy needs like this, we need to have more cables, more transfer routes. We need to go do offshore energy generation, but we also need to have more decentralized energy generation. And the energy business is going to be, they're hurting right now, and they're hurting because of all the old stuff that they have to go and deal with. But overall, it's going to be one of the hottest spaces, I think, for the foreseeable future, because they have hard challenges.
Yeah, and they also sometimes you see the problem being turned around, right? That the electronic cars are starting to deliver back to the net, actually.
Well, because they have, but that's a function of them just having good batteries, right? And so they can go and bridge the gaps that comes out of the renewables. Our electricity story is going to look very different in 20 years.
Yeah. Okay. You told us a little bit about APIs for cities, for states, for buildings. What standardization solutions are you seeing there, or what movements are you seeing there?
There is governments with smart city initiatives. One smart city initiative that's fairly far ahead, I think, is Singapore, where it's relatively easy because Singapore is a country that's small, and it's also it seems fairly simple in Singapore to do something from the top down, which is probably there easier than in other places. I think this is going to go and be a thing where we see cities doing things first, and then we're going to see states picking things up, and then probably going to go and have some federal things. I think the EU can go and play a really good role here to go ahead and start doing this. This would be good regulation in that case, to go for the EU to step in and say, let's go and do some minimal first steps in the kind of, every city should go and offer this following service, or every state should ever offer all of this following service. I think that's something that will come from the government level.
Okay, well, Clemens, thank you again for your inspiring talk. Everybody, big applause for Clemens.
Thank you.